This video will discuss the solution to question 17, which goes as follows. What should be the minimum specified input common mode voltage, V in Cm, so that all transistors remain in saturation? Now, the transistors on which this voltage has the most direct effect are MP1 and MP2, but because the circuit is completely symmetrical in the first stage, we can just look at either one of them. So let's choose MP1. MP1 needs to follow the following constraint to be in saturation. VSD P1 should be larger than or equal to the overdrive voltage of P. However, unlike in the previous question, we don't know the source voltage or the drain voltage of P1 yet, so we need to find those using some other method. The source voltage of P1 can be found using the definition of the overdrive voltage. So VSG P1 is the same as the overdrive voltage of P plus the absolute threshold voltage of a PMOS transistor. And since the gate voltage in this case is nothing more than the input common mode voltage, we can say that the source voltage of P1 is the same as VOVP plus the absolute threshold voltage plus V in. Let's call it V in. Now we can also already fill in some numerical values. The overdrive voltage of a PMOS transistor is given in the caption here, that's 0.3 volts, and the absolute threshold voltage is 0.4 volts, so this is 0.7 volts plus V in. To find the drain voltage of P1, we can use the fact that the NMOS transistor has its drain and gate connected directly. That means that this voltage right over here is just the same as the voltage drop from the gate to the source of Mn1. And to find the gate source voltage of N1, we can use the same knowledge of the overdrive voltage that we applied above, but then for the NMOS transistor. Filling in the values from the caption, which are 0.2 volts for the overdrive voltage and 0.5 volts for the threshold voltage, will give us a drain voltage of 0.7 volts. The final step is now to fill in the values of Vs and Vd into the constraint above and solve for V in. And the overdrive voltage of P was also given, that is 0.3. So the final solution here should be that the input voltage should be larger than or equal to 0.3 volts, and that is the correct answer.